Assalamualaikum and a very good day to everyone. Hi, my name is Nurhazirah Hasbi and my supervisor is Professor Madia Ahmad Kamel Hussain. Today, I'm going to present about my final year project 1, that is analysis on hard points of sandwich panel of a skateboard. Before we dive into the details of this FYP1, let me introduce to you what will be covered in this project. There are 4 main topics that I will be covered, starting with the project summary, the introduction, followed by the methodology, and lastly the expected results. Firstly, I would like to give the summary of this project. Skateboarding has become a pop culture phenomenon in recent years. We can see it on television, in fashion shows, and for the first time in history, skateboarding is included in the Tokyo 2020 Summer Olympics. There are 2 variations of skateboards that can be found, that is longboard and the shortboard. Initially, the material used for the mass production of skateboard is wood, a natural composite material. In this study, new composite material in the form of sandwich board under various flexure loading conditions will be analyzed. Soft aluminium honeycomb will be used as the core, and 2 relative rigid aluminium sheets are used as the face sheets. A truck that is a T-shaped piece will be mounted onto the underside of the skateboard deck and is mechanically joined by using fasteners. Since the core material is weak, the hard points have to be formed, also known as inserts, to attach to the truck. Hence, another objective of this study is to analyze the behavior of the hard points, that is inserts, on the honeycomb sandwich panels. In literature review, there are 2 elements that I will focus on. That is first, the 3 points bending test, and the second one is the inserts pull out test. For the 3 points bending test for skateboard, in a research paper titled Flex Analysis of a Composite Skateboard, written by Jared Hillick, stated that by doing the 3 points bending test, the stiffness of various composite materials can be calculated by using the finite element analysis. Next, that is for the pull-out test for inserts. Nicole Ragu and Mark Betley, on their research titled Strength Variability of Inserts in Sandwich Panels, stated that the behavior of the core in the inserts can be investigated by using the pull-out test. In their research, they also use finite element analysis, that is by using software. Proceed to the problem statements. As we all know, most skateboard decks are made of wood. To be specific, the maple woods. In an article written by Sinto, stated that as the demand for skateboards grows in the industry, which manufactures an estimated about 100,000 boards per month, is becoming a major contributor to maple deforestation. Deforestation is a major environmental concern that damage natural ecosystems, increase carbon emissions, and poses a threat to local plant and animal population. To address this issue, A more resilient and sustainable sandwich panel than maple can be used to make the basic material for skateboard decks. So the first problem statements would be the suitable material for the sandwich panel structure of a skateboard deck. Next is the type of loading on skateboard need to be identified, and how the deck will respond to it is very important in order to produce a good quality skateboard deck. Next, as the sandwich panel will be used in this board, an analysis need to be made to evaluate the capability of hard points on a skateboard deck. For that reason, the third problem statement will be the ability of the hard points created by the metal inserts to withstand the support loads. From the problem statements, three main objectives have been created. That is, first, to select a suitable new sandwich material for the skateboard deck. Second, to identify the types of flexure loadings on the skateboard and analyze them. And the last one is to evaluate the capability of hard points on the sandwich panel to support loads. The scope and limitations of this project are as stated in the slide. That is, first, a standard long board is chosen for the analysis. Only one sandwich structure will be modeled and analyzed. And the last one is to focus on compression test and to analyze the insert behavior. Following the scope and limitation is methodology. For this final year project, I have created a flow chart. As you can see in this flow chart, the first block, that is from the start until the type of insert and skateboard design, is planned for my final year project 1. And the second box, that is from the analytical analysis, CAD modeling, simulation, analysis and discussion, and lastly is MEC conclusions and recommendations for my FYP2. Next is the description of test. For this analysis, there will be two types of test. That is, the first one for the insert and second one is for the sandwich board. For the analysis on inserts, a square sandwich panel that is 80mm length will be designed. The panel is then tested by using the pull-out test. The diagram shows how the setup will be. For the second test, that is for the sandwich structure, a complete longboard made out from soft honeycomb aluminium 3003 alloy sandwich by aluminium 5050 alloy face sheets. After designing the model, the skateboard will be tested by using the 3 points bending test. Lastly is on the expected result. Item 1 shows the expected design of the inserts, where the honeycomb structure will be drilled and metal insert will be put on the hole, and potting agent is filled into the insert. Next, item 2 shows how the expected test on the skateboard will be. From this 3-point bending test, the result on the bending stress of the sandwich structure will be observed and will be generated in a tensile stress and strain as shown in the diagram of item 3. for preliminary results, I decided to study the 3-point bending test of a sandwich structure by using abacus software. In this study, a sandwich structure with a length of 548.48 mm and a width of 100.98 mm is created. For the honeycomb, a hexagon with 5 mm edges is created. From this study, I have learned on how to build the sandwich panel and generate the result by using abacus. That is all from me. Thank you for listening to the proposal of my final year project 1. Have a nice day and Assalamualaikum.